Okay, hi everyone. This is Samir here. Your host for this series. So we're calling this observability in the wild because currently I'm on the search for talking to the experts on the field actually and see what their experiences are with observability and implementing observability in their specific organizations. So we're gonna go beyond the set definitions of what observability is and how it should be, because we all know that's a subjective conversation that we can have with experts that are actually implementing it in the wild. So today I have Vipul Gupta with me. I will hand over the stage to Vipul. So Vipul, if you could please introduce yourself and where you work at.
Hey Samir, thanks for having me here. I work at Belina. I'm a senior software engineer there, and we build infrastructure for IoT devices for easier management, for deployment, for debugging out there in the wild. We have a lot of IoT devices out there doing very important things, and Belina provides the platform to manage all these devices, debug them, deploy new code on them whenever they fail. You can also search into them and do the lifecycle changes on that device anywhere in the world.
Okay.
On the team, I work in the hardware in the loop team. So I work quite a bit on the pipeline systems as well as our hardware in the loop pipelines, where we test actual software on real hardware, all automatically or at scale. That's where one of the problems came out, and that's where we are here, which was monitoring and observability for our CI/CD pipelines, which is quite massive as a
Right.
challenge. And
Right.
yeah, we built our own observability solution. We can talk more about that, but I do developer education efforts at Balina as well. I'm the lead documentation maintainer. And,
Nice.
as startups go on, I wear multiple hats
Yeah.
at the company. So lots of
Yeah.
things to do.
Cool. Absolutely. That sounds really amazing. So from what you've told me, observability and monitoring again obviously is a big part of your the operations for your company.
Mhm.
So what stack are you currently using? I mean, you can tell me about the developer or operational stack as well as any observability specific technologies that you guys are using.
Sure. I worked indirectly in evaluating and implementing a GitHub Actions observability stack at our
Okay.
company for our CI/CD systems. For our backend, we use traditional monitoring tools like Grafana, OpenTelemetry, Prometheus. In that way, for measuring our metrics, failure rates, for our components like the Cloud Link, for our backend systems as well. But something unique that I've been directly involved with is building out a GitHub Actions or a CI/CD observability platform using
Okay.
open source tools out there, as well as tools that are already there, like Sentry or Datadog, something like that. And in the past, we were flying blind in terms of all these automated updates that we are having to do, as well as the hardware in the loop pipeline, which I mentioned. And the project came from a real pain point where we needed actual CI/CD monitoring or CI/CD observability, and GitHub was not scaling up to the challenge. The native insights that GitHub provides just doesn't give you the bigger picture on what's failing, what's there in its failure mode,
Mhm.
what's the lag in a particular span or a particular task that
Right.
is happening in a CI/CD pipeline, and having a way to look over hundreds of workflows and figuring out what is missing. That is the key visibility that we needed for workflow trends, failure patterns, and performance bottlenecks that were simply weren't available out of the box. And that's why observability helped out in our project.
Absolutely nice. So you're using a lot of I would say a lot of OSS, open source based, open telemetry kind of instrumentations,
Mhm.
um, which is I think a de facto, a default for most of the companies now. They're all moving to open telemetry and keeping their options open, so to say.
Yeah.
So how involved are you particularly when you're making a decision as to
Mhm.
which stack should we include in our observability stack, and how should our
Mhm.
strategy be when it comes to observability?
For me, I'm directly involved with the process.
Okay,
It's something that
awesome.
I'm both the customer, like the consumer of those metrics, as well as the producer in that regard.
Nice.
So, like the pipelines are maintained by us and my team. So we are the ones, maintaining this pipeline, trying to see where the bottlenecks are, also figuring out how do we scale up. And then in the end, we are also building the observability pipeline as well to find bottlenecks, the bigger picture, define failure patterns, also task other teams to sort of fix the failure bottlenecks that we are finding, figuring out, deeper research into the pattern, because without actual work going into observability is just metrics, just some
Yeah,
shiny dashboards that you can have. But teams need to
absolutely.
come together around the data to actually implement and execute on solutions. And I think that is really important. For achieving observability at Billionaire, we have been working very hard towards um, with observability, it's often like a reactive firefighting where the fire is in terms very unknown, right? It's something that
Yeah,
we need to build understanding upon, we need to build certainty upon, so that anytime this fire explodes or it spreads, you know what's happening in the system. And that's
yeah.
where Balina comes into the org, where we have been building on a reactive basis rather than a proactive basis. And that is changing for the last few years, where we've built systems and platforms already in place to handle at scale, to handle, make sure we are catching the errors. We might not see very much edge cases, and that helps us quite a bit. It also helps us provide, data-driven decision making for our platforms, so that we can now make decisions based on actual data and insights instead of, yeah, just let's just scale this pods, right? Or
Yeah,
just make this deployment bigger to solve the
yeah,
problem, throwing money at the problem or throwing money on this fire, right?
yeah.
Um, at the organizational level, observability means quite a bit when we are supporting 100 plus devices. So a bit more about Belina is we have a lot of devices that we support on the hardware level. So about 100, 150 plus, and each device gets an own operating system. So completely different operating system for each of those devices. So you can imagine the scale of a CI/CD pipeline like this, where we're
Yeah.
building a completely Yocto-based embedded Linux distribution for each separate device. And that creates a
Mm-hmm.
lot of challenges. That creates also a lot of hurdles in terms of how we track such a pipeline, right? And how maintenance gets done. Because these pipelines fail constantly. Your dependencies being injected, Yocto gets updated a lot of the time. And some critical gaps that were left on the level was trend visibility, pattern recognition, and basically performance that we were
Mm-hmm.
lacking. And that's where observability came into quite a clutch for us. And that's where the major decisions come from. So, yeah.
Cool. Yeah, so you said something very perfectly. It's like observability often feels like fighting fire after
Yeah.
it has spread, but
Mhm.
that's not it. That's not how it should be, and that doesn't have to
Indeed.
be. Observability basically is much like DevOps is a practice, not really. You can't just throw money or just can't throw tools at
Indeed.
observability problems and just expect for them to just disappear by their own. So it's more like fireproofing rather than firefighting. I think like so a proper observability strategy should be prevention instead of curing problems after the fact. So yeah, I absolutely agree with everything that you said. So you said you mentioned you have a lot of hardware and you have a lot of operating systems, you have a lot of pipelines, etc. So in terms of your organization or personally, you may have your own personal opinions as well, obviously. Um, at what point would you say that okay, at Berlina we have achieved observability, even if even that it's a thing? I don't think that you can say that okay, I'm
Yeah.
done with observability now because it's an ongoing practice. But at what point of time do you say that okay, we have achieved at least a satisfactory level of observability
Mhm.
in our organization?
Thank you. That's a great question. A lot of people try to, go towards 100% observability. And even
Yeah,
that, creates like, I feel, factors where it might not be the best thing ever for the organization, pushing for 100% observability and finding
yeah,
out, because that's not the right usage of engineering resources. Because, like I mentioned in the starting, right, fancy dashboards and just having the metrics in hand doesn't actually net you the profits.
yeah,
Just like the analogy as you were using, right, fireproofing, I would better say it's not prevention. Observability is not prevention, it's the diagnostic tooling to find you the cure.
Right.
which will help you prevent things. And just like a CT scan machine, which is very complex, right? And tries to figure out what's wrong with your body, that's what
Yeah.
observability is. And CT scan machines didn't just appear overnight. Just like with organizations and leaders, when something goes wrong, you
Yeah.
can't just create
Absolutely.
observability out of thin air and start creating problems. Maybe with AI in that regard, I can feel that might thing happening. But even AI requires that
Yeah.
particular visibility. So the tooling needs to be set up by someone, and you need to have the history of data. But I follow the classic principle of you can't you can't improve what you can't measure, right? And this is something that is quite critical when you go for challenges in the observability space. And the idea to have 100% observability, just like 100% testing doesn't help the entire testing coverage. Uh,
Yeah.
unless those tests are being worked on, unless the teams come together to look at the observability data together, and rather than having like an analysis team giving you like, oh, this thing failed. For having the most effective observability methodology in a company, I would say it needs to be very bottom up plan. And needs to the effort needs to come from each individual contributor or stakeholder in that regard. Everyone looks at the data together, works on it, rather than alerts being sent. Because the next thing that you do, which is like the funniest thing I feel, the next thing you do after figuring out observability is how to figure out alerting to the right person. And you figure out alerting for Slack, alerting for wherever
Yeah.
you are wanting to send notifications. How do we implement it with the reliability ops? And that seems very funny to me because considering how important observability was, you're having to now come up with a situation to now get people to know about. So something that we have done, like at least in our space, is making sure everyone should look into the data. We have designated times that we are building right now. It's also sort of new times for us because of the CI/CD observability platform that we just
Mm-hmm.
introduced.
Mm-hmm.
So the alerting is we are trying to get it on the bottom up stage where people can actually go and check the data themselves. There is onboarding guides on how to use the platform at the point, and that way it not just there is no like I don't think you can remove alerting, but it is very nice where everyone in the team is actually caring about the data and actually talking
Yeah.
about what's going wrong, right?
Yeah.
And that's where I feel like you don't need 100% observability at that point because the bottlenecks are then identified by teams only. Like when they are looking into data so much, both the consumers and producers, right? Then you have a situation where the bottlenecks already get identified and the team will serendipitously move towards a part which is 100% observability because 100% of anything is not that useful, even with testing.
No.
So you need
Yeah.
to have the most critical parts covered, get that data in, and then find what is the next critical component we need to measure, and then improve that system. So yeah, that would be my take on the 100%
Yeah,
observability system.
absolutely. Totally agree. You talked a lot about alerting and sharing data out of the
Mhm.
observability systems because it is equally important to share your data as it is
Yeah,
to create it and to observe it. So that obviously pivots us nicely to data visualization, let's say. Um, how do you, in your organization, share out the data from actually that is collecting? So metrics, logs, traces. Okay,
sure.
fine. As a developer, they are good to me, and fine. I'm collecting them. I'm instrumenting them, sending them, storing them. But
Mhm.
how am I sharing them? Because the nothing is of use if there is no insights to draw from the data, right?
Indeed.
So how are you actually sharing them out, and what is your view of the on the role of data visualization in all of these observability platforms?
Absolutely. Again, we come into another evolution on we can't improve what we can't measure, and
Absolutely, yeah,
we can't visualize what we don't measure as well. In that regard, you can collect every sort of metric available from a system or a pipeline or even like a deployment that is there out there in the application layer, but having that sort of visualize and be able to sort of read that quickly in like less than 10 seconds and understand what's going on with their application, that is where key data visualization comes in. And something that we really realized is having easier dashboards as well as unit based dashboards have been unit metric wise dashboards are very important. One dashboard, one metric only, very simple to figure out, even if your visualization dashboard where everyone looks into is quite comprehensive, at least you'll have sections where, okay, if my specific part of the deployment is failing, I can just look here. And that is
Mm-hmm.
really key for simplicity, for the firefighting element, whenever that comes across in an observability space, as well
Mm-hmm.
as doing just debugging, right? For people to not query so much in terms of figuring out what's the actual problem, rather than the dashboard helping them figure out where is the diagnostic issue and where might be the root of the problem, and then they can start querying that way. So in that way, visualization helps quite a bit. We use Grafana for that, and we also use like a tool that is already out there called Sentry. So
Mm-hmm.
With Sentry, we do that quite a bit, where Sentry already provides like an insights layer baked into it. So all the data gets collected into Sentry, shown as like the dashboard that we custom built for our teams. And then you can use this insights tool to actually go and query all the parameters, all the metrics to figure out, okay, what's going wrong, and create your own pattern recognition to find the root cause of the problem. So yeah, in that way, for visualization purposes, it also helps people find what metrics we are collecting very intuitively. This is something that is quite key, because you can again collect as many metrics as you want, but unless you are properly visualizing them, people don't see the value or the
Yeah.
power of those metrics, right? So like
Yeah.
something I can give you an example in a more CI/CD use case is retry count. So GitHub Actions can let you retry a particular workflow as many times as you want. And some of these workflows can be automatically retried as well if you have webhooks or API calls built in. But you can also be retrying. And as like an OS team lead or a hardware team lead that we have in the devices team, they can actually look into, okay, what workflows that are being run in the past 90 days have been retried more than 5 times. So we can
Yeah.
actually find out these specific workflows that are being very troublesome, right? So these are not failures. These might be, 4 times it got retried because it couldn't find the right resources, because we have a more hardware level limitation as well involved with us, where you might have no hardware available to test your software on. So it
Mm-hmm.
might be just a race condition or a bottleneck on our hardware
Yeah.
scale. But it gives you
Yeah.
that insight that you didn't have before, that, okay, the 4 times it failed and it couldn't find something is because of hardware. So yeah, maybe we can add a new worker to our rig and improve on that bottleneck, right? This job is being tested quite many times, and we can see major instances of this being failed because of a hardware failure. But then also we can find out on a level where, on hardware observability at least, you have a situation where you need to find a pattern, right? So figuring out, let's say an SD card is failing for one of our rig devices. How do we find out with just one test job failing? Because
Yeah.
with hardware, the problems are not very reproducible as well.
Yeah.
You have multiple factors coming together to create like this failure case. And that way
Mm-hmm.
you need to, have this history of data, the pattern, right? To find, okay, this is going wrong. And that way it helps quite a bit in a team level. And then bringing together that visualization to show, okay, like failure counts are this many for each device type. If we see it above a threshold, then someone can investigate and find out what the problem is with that device, or change things on the hardware level as well. So we have, for us, it's not just the software CI/CD layer, the software running and then building on the CI/CD part. It's also a real hardware element. Just like, let's say, if your CI/CD workers, like if you're running them on Hetzner or AWS, or if you're using the GitHub runners as well, if they start failing, then you also need to figure what's happening with them. And
Yeah.
that's the complexity that we have at Belina, where we need to handle our own runners and figure out what's happening. So more than the GitHub action runners or the free runners that are available, we also need to look into our own hardware level runners as well, and that increases a whole lot of complexity and challenges, because they require their
Yeah.
own observability stack.
Absolutely. So you bring up some key point there. So you,
Hmm.
as is with many alerts or many root cause investigations, you need
Sure.
a single source of truth, right? So
Sure.
because all of these or most of these alerts are contextual.
Hmm.
Like in your case, you have hardware failures that are not very
Yeah.
reproducible, but at some point of time, you I'm sure that you want to go back in time and
Hmm.
see if this same alert had been raised previously
Yeah.
on one of the other devices or on the same device. And then you want to see that in context with the everything else, the software components, maybe the OS components, the kernel, the hardware, or whatever, right? Your CI/CD pipelines.
Mhm.
So this an alert is really isolated because,
Yeah,
as you pointed out, it is a culmination of a bunch of elements coming together and making something fail. So, what is your single source of truth here, and how do you manage it?
right on. And the bigger question is, do we trust it?
Do we
And
trust it?
that is
Absolutely, yeah.
that is something that a lot of teams have to deal with, and a lot of people are not talking about an observability spaces like the trust in the platform when it's quite new, right?
Yeah.
How do we start building trust at the foundational level? That's where my topic or point about metric wise observability or the visualization comes in. So don't make your
Mhm.
dashboards too complex, make them very solid, very simple in that regard, so people can actually start getting trust in the system. They can see the insight that is being collected also on the application level, or
Yeah.
whatever is being tested, right, or being observed in that space, to actually find out if I can trust this data being collected. And that is one of the key things at the very start that makes or breaks observability. So in that regard, um, the question was, how do we figure out the observability in a team,
Yeah. What
or
is your source of truth? I mean, where
what
do
is the
you look
source of
for
truth?
when you, yeah.
Indeed. And the source of truth really comes down to, like, the the pipelines that are producing, and especially for us, it's quite complex. We can't narrow it down because
Mhm.
considering the problems are so isolated, you have a situation where I was just thinking about something. That's why my train of thought is not working. When you mentioned this thing, right, where the with the error that causes, and alerts are very isolated. It's actually very true. Just like fever in the body can just mean hundreds of different things, it is the
Yeah.
only diagnostic element I'm seeing. So alert is like fever in that regard. And it could be that, yeah, I had a weather change and my body is struggling to, figure out how do
Adapt.
I
Yeah.
deal with this, to my
Mhm.
kidneys failing. Exactly as you put it on Google, it goes 0 to 100 very quickly for any
Yeah.
problem. And that is
Yeah.
what really observability could be about, when you have that single source of truth which you can rely upon, which you are trusting, and how that comes across in a team where there's a lot of fever happening in the system. Is it actually fever? Is it like fake? Is
False
it something that
positives.
is,
Yeah.
can be fixed by its own regard? One retry later, it might be fixed as well, considering we have a lot of transient failures, right? We, in our pipelines, especially, observability is incredibly hard because we have a ton of transient failures in the system. With like the hardware failing sometimes, the network is not working. A lot of these IoT devices are very finicky with the internet as well. So any failure in terms of like the pipeline. So we run like each job for about 3 hours. And in that, anytime like our cloud link connection fails, or something like the device is trying to figure out, or it may run out of resources, you have a situation where the device just failed. So
Yeah.
trusting that source of truth is quite important. And for us, that would be Sentry, where we have deployed our, where we are sending all our metrics from our GitHub Action pipelines into, and then visualizing them right at the platform as well. Uh, we are also thinking about moving to a more open source observability platform. So I'm actually implementing right now an open telemetry GitHub Actions collector, and then that
Okay.
sends insights into Grafana. So I'm rebuilding the same thing to sort of catch those errors, because something that is happening in the CI/CD space is it's quite new right now, and that's one of challenge as well in the source of truth problem, right? uh,
Mhm.
the space is quite new, is quite maturing. So no particular solution I've found right now is able to catch, and I've done the research like last year, so maybe new solutions have come up. Signos has released a new open telemetry GitHub Actions collector because they are based on it, so Signos has their own dashboard. But this is something that we need to figure out, how we can get the errors out of the CI/CD system in a standardized form and give them into our observability platform to find that source of truth. Right now, we collect like a lot of these metrics and spans where, okay, these are the amount of steps that run. Let's say you have a npm install step in your GitHub Actions pipeline. Then how long that step run? Was that step successful? But that's about it. Let's say that step failed, right? I have no actual visibility on why. Now I have to click another
Right.
link and go inside. So in that
Mm-hmm.
way, my observability platform is not working, and my
Mm-hmm.
source of truth is still GitHub. So what is
Yeah.
happening right now as our first step of deployment? We have given our team a bigger picture that they didn't have with GitHub Actions, because with GitHub Actions there is very less query, and especially you can see only like 15 actions on the main page, and that's about it. So having that sort of like a 90-day view of all the actions running and finding, okay, the Raspberry Pi 3 devices, right? They're failing on this step quite a bit. Let's see what's happening. And that way we have been able to get that insight. And that's where our source of truth lies. But I feel like it's going to shift left quite a bit, where it needs to be somewhere in between GitHub Actions and the platform, where the
Mm-hmm.
platform takes up that source of truth quite a bit. And what I'm doing is try to shift left towards the observability space and how we can get errors recording into it. So
Yeah.
quite a bit of issues in that regard. Something it's a major challenge that we are trying to solve, considering the space is quite new as well. And
Yeah.
as we have met, I think before, we are constantly writing about it as well, trying to improve the entire space for everyone in that regard. So yeah.
Absolutely. Beautiful. Beautiful answer. Um, while we are when we are talking about tech nowadays, we cannot not talk about AI.
Sure.
And observability again in my opinion, is one of the prime candidates for AI integrations, because we've talked a
Mhm.
lot about like tons of data and contextualizing all that data and giving me meaningful alerts, because I don't
Yeah,
want to be flooded with alerts at 2 a.m. in the night. I just want to be notified if there's like something worth waking up for
indeed.
at 2 a.m. So, and AI obviously can help quite a lot with contextualizing things, from taking from different sources and combining them, summarizing them,
Yeah,
even maybe categorizing them, prioritizing them for us, maybe based on some preset preferences set by us. So in your organization, or in your observability strategy, where does AI fit in? Are you using AI actively, or a lot of the tools nowadays are just coming with AI capabilities by design? So are you
indeed.
making use of these AI capabilities yet, or do you still not trust them enough? Because
Right.
personally, I'm not very. I like AI, and the things that it offers, but I'm not quite sure of whether I can trust what AI says, because it still has the problem of hallucinations and context windows. Maybe it's leaving
Yeah.
something out. Maybe it thinks that something is not important while it is for me. So how do you tackle with this problem? What's your opinion on this?
Yeah. I feel I am genuinely excited on the AI's potential in the observability space. We're already seeing very interesting approaches out there on like platforms that are built completely around
Yeah.
with an AI detecting patterns in CI failures. So like this is something that I've already seen in my past research with something called Mergify, right? Having a situation where they can, find errors. But again, the contextual limit, as we mentioned, as we talked about in the past, like how alerts and errors could be isolated incidents as well. That context, how can we, train the AI, train the LLM models to understand that well, figure out how they can work things up, and that kind of pattern recognition and I feel root cause analysis is where AI can really impact
Really
our
shine.
work,
Yeah. Yeah.
really help us with a lot of the workload that we are having right now, where humans are terrible on the analysis part, at least on a big data level. If
Yeah.
there is isolated data and it's something that can be reproduced, where it doesn't require a lot of context, an AI use case can shine. But I'm also very cautious about the hype. AI is only as good as the data is trained on, right? And in many cases, it's still all about figuring out if we are getting it the right data, if it's collecting the right data as well to figure out those insights. And I think the most successful AI integrations will augment human decision making rather than trying to replace it entirely. Having a sort of way of actual reasoning, not like the reasoning that was there in the starting for LLM
Yeah.
models,
Yeah.
having a way to
Yeah.
actually reason about the data, use the same decision making that humans use as a way of figuring out step by step how I go about, you know, X and then trying to reach Y, what might be the root failures, what might be the causes of Y, figuring out all the reasons, and then giving me a good analysis on what an error is, what can it mean. I think that's where AI shines quite a bit. The summarization aspect, the explanation, and as it understands more context, it can do root cause analysis. It can do intelligent alerting is something that we think, where
Mm-hmm.
instead of having just filters on the metrics and then creating alerts on those basis, you can have an LLM tool actually figure out if this error is critical, actually
Yeah.
critical in a level, rather than just, yeah, if it's not my P99 or P100 of my error, then this is the problem that I'm facing, and just make an alert over it. And
Yeah.
what that does is, right now, what that does is you have a mountain of alerts coming out of your observability space. Again, no one to look into, no one to see if they're real. And once you have created a pattern in your team where the observability platform might be creating, how to put it politely, dummy alerts, team
Yeah.
stops caring.
Yeah.
And it's human nature, right? Like something that is not useful, humans stop caring about it. Or something that has become too simple, right? Like something that is too simple in the pipeline. We as humans don't really care how much goes into it. So we are also not investigating if it is the right source of truth. So either we are blindly trusting or not trusting at all. It's always 0 to 100. And in
Yeah.
that way, AI needs to also prove its part, where it can also provide us like these predictive insights by not just telling what happened, but also predicting where systems might fail. And this is something I really want to work towards in the future, where we can have predictive CI/CD elements by figuring out where the bottlenecks are, and having a situation where these bottlenecks can be, let's say, let's say the NPM install took a second more, right? Or maybe the build step took a second more, and it can figure out, okay, from this last PR that made this code change, I had this much data on whatever my action took time. This next build took 10 seconds more, and I can find out exactly where the development pipeline is going, predictively figure out, okay, this is the next thing
Yeah.
we can do to improve our build times. That is
Mm-hmm.
something that would actually be helpful, because humans then will have to spend a lot more time doing this calculative
Time.
thinking
Yeah.
and
Mm-hmm.
doing the making that pattern fit. For us, finding patterns is quite hard. For LLM systems, it's quite easy. And I think that's where the strength, we can use that strength to find like these predictive insights to help do preventive maintenance than reactive maintenance on the pipeline. And then actually, do like, um, it can read change logs for us. So let's say I'm building like I have a Python build system, right, for a package. Then it can actually check out a Python change log and find out if I upgrade to 3.9 or 3.11, then we have this particular performance bug that will actually be helpful for us. That sort
Mm-hmm.
of thing takes weeks for humans to figure out, or entire
Absolutely.
teams when they're working on a problem at that point. And I think that is really key, um, for AI to come in. Again, long way to go, but considering how the development is made, may not be a long thing for models to catch up to having this sort of context window. That sort of training, especially custom training, would be very helpful for a particular
Yeah.
general large language model. A lot of teams right now, and since I work in that space as well, I really love to look into AI evaluation space. This
Mm-hmm.
is a situation that is coming into where a lot of the teams are building very small models that are open source, like Quen or Gemma. Gemma is no small thing for any regard, but it's hyper optimized. And or even Lambda is quite used there in local deployments, and training it on a particular set of data for a customer and then giving it. So like your own personalized AI would be a solution I feel like would come up
Nice.
as the right way for observability space and actually make a real difference, rather than just providing, yeah, explain what happened, right? Explain this error,
Yeah.
which is something that Copilot does right now in the GitHub Actions pipeline. And while it could be very useful for a beginner, for someone that is coming in, usually it happens where if it can tell me, if I tell it to explain this error, it also tells me, yeah, hey, Vipul, it happened 6 times before in the last 10 days. The last 6 times it happened, we worked on this thing and it didn't fix that. Or we tried alerting
Yeah.
it, but the team hasn't responded yet and the team is working on it.
Mm-hmm. Mm-hmm.
Contextual, right?
Yeah.
Contextual patterns, using all the context it has to give me like a clear picture. So my job is next is whatever roadblock is there for solving this thing immediately gets identified. immediately get tasked or gets fixed, and then the AI can exactly see how the improvement is for that solution as well. Yeah,
Yeah.
although a lot of these are very human things that we do, and that is something that the LLM can solve very well if it replicates our thinking rather than replaces how we solve things. And since it's not completely an AI-driven system right now, we can't say like okay, how do we actually find out what things AI will do differently. So right now, for a lot of the teams and a lot of the observability solutions out there, I'd recommend going through this path and seeing if we can replace humans in the equation, which is something that we mentioned quite a bit in our own pipeline, which is hardware in the loop, right? The
Yeah.
hardware in the loop case only came across as something that we did to replace the humans out of the hardware testing landscape. Humans are incredibly clumsy. We are not reliable systems in place,
True.
and our fingers make mistakes all the time, and we
Yeah.
make mistakes all the time. We also need a lot of energy to do simple tasks
Yeah. Yeah.
for us. And for systems, it's quite complex. So I feel like with LLM systems, they're not replacing us in that regard, but actually doing things better. And why not use better tools in the toolkit rather than keep using humans in that loop? Humans can do like a lot of more predictive analysis or at least analytical parts to
Hmm.
apply AI in a certain way. So yeah,
Hmm.
that would be my hot-ish take. But I feel like the lot of industry is also there in that
Yeah.
regard.
I was actually going to ask you. My next question was, do you have
Sure.
any hot take for us to keep in mind or take away from this discussion?
Hmm.
You've kind of already given me.
Hmm.
Um, while I mean, I do agree. There are some moral implications, let's say, or being
Sure.
politically correct, whether it's like, should the systems be replacing humans? Is it good for the
Hmm.
society? Is it good for the technology? Is it good for the humanity in the long
Sure.
run? Um, but yeah, I totally agree with you when it comes to analyzing big data patterns,
Yeah.
things like that, repeatability. If you want to, avoid some duplication of efforts, then
Yeah.
for sure, absolutely, why not use AI systems which are much better than identifying pattern than human beings. So yeah, I totally agree with you. So
A
I think
common
we
a
are.
common thread in KubeCon is something
Uh-huh.
that we recently attended. A common thread with KubeCon is a lot of people and a lot of talks that you might have seen has
Hmm.
been about where there are tools out there, and that's like the entire topic of platform engineering is coming into play, where you have a situation where people are moving towards replacing like an entire team of DevOps worth of things
Oh
into
yeah.
a one-person
Hmm.
army,
Hmm.
and that one-man army can figure out a lot of the solutions, and that one person can actually be in control a lot of deployments, usability, not just responsible, but a lot of the team is actually using those tools it creates, it just maintains that person. So in that way, like I understand the economic prospects as well. I am especially into a situation, or the last 2 years of my life have been devoted into like learning about AI safety and alignment in the past. So yeah, there is extreme economic situations and consequences
Yeah.
of this thing, but there is just no way to sort of ignore a system that is better. Uh, we can only delay the system in that regard. And
Yes, that's true.
that would be my hot take, at least AI. But something on just the observability landscape, I would want to say like one thing uh, that is quite important is be ruthless when it comes to your requirements. Be ruthlessly specific about what you want to build. So something that we started off is whenever we look into the observability space right now that I'm looking again to build like this over telemetry and Grafana integration into our CI/CD space, I
Hmm.
built something called a shopping list. And a shopping
Okay.
list is basically all these things that our existing ecosystem is giving us, as well as what we need later on. So you have the present accounted for, as well as the future. And that actually helps you build an observability solution that stands the test of time. So your team doesn't have to pivot every single time when something new comes into place, or even with AI, right? Like if you chose the right platform, they might offer an AI integration later down the line. And that really helps. Or you can build your own AI integration, at least that's the freedom you're getting. So having that sort of future mindset would be something I'll recommend to all platform engineers or observability teams to be very specific about what the requirements are and build only for that. Don't go for 100% because being perfect is the enemy of good in this regard. We're having good, and the difference between good observability and great observability is that little extra effort that you put into your requirements and then figuring out
Absolutely.
what
Yeah.
exactly gets built, what exactly it is to mean when it's perfectly tailored to your needs. And the immediate value of getting that basic observability up and running for your entire team is much more important than, again, what we discussed is 100% observability case. So yeah,
Yeah.
uh, that's the two things I would mention.
Cool. Absolutely. That's the code of the day. The difference between good observability and a great observability. Yeah. Totally agree with you. Thank you, Vipul, for spending your time and talking with us. Thanks to everyone else who's joined us for this Observability in the Wild series. I hope you got something useful out of it. I'm sure
Mhm.
if you have any questions, Vipul will be, more than happy to connect with you and answer all your questions. While I'm uploading this, I will drop Vipul's socials wherever he's on, in the comments or in the description wherever. And also mine if you want to connect with me. And if you are an observability expert, feel free to contact with me. And if you want to be a guest in the series, I'll be happy to host you as well. Again, thank you, Vipul. Thank you for the incredible insights. I personally learned a lot. So I thank you for that. And hope to see you again in one of the other episodes, maybe down the line. I'm happy to have you again.
Thank you, Sabir. Yeah.
Thanks, Vipul. Okay, that was good.